All right, kids, we're back. D5 quiz coming right up. Question number 1. This is 20 questions, 2 points each, 40 points. What is the mass of a 5-liter object with a density of 3.5 kilograms per liter? We're looking for mass. That's got mass in it. Let's start with that. 3.5 kilograms over liters. Now, we got to get rid of that liter unit because we don't want it in our answer. So we'll multiply by 5 liters. My liter is going to cancel out. 5 times 3.5, that sounds like about 17.5, doesn't it? Kilograms? Yes, check your math on a calculator if you want. All right, let's move on. Number 2, which of the following is the best example of a chemical change? Ooh, boiling in of ethanol. No, it's physical change. Sublimation of snow. No, it's just a phase change, right? Phase change, phase change. Rotting of an egg. Ooh, yeah, you're making something new. You're making something stinky. It's called hydrogen sulfide gas. That stuff rots, okay? The melting of ice, physical change, right? You're just changing phase. That was simple. Moving on to number 3. Scroll up here. All right, what is the volume of an object with a density of 13.1 grams per cubic centimeter and a mass of 65.5 grams? Now, these are shuffled, right? These are not in the same order necessarily that you saw them. All right, what is the volume of an object with a density of 13.1 grams per cubic centimeter, mass of 65.5 grams? I need volume in my answer, so let's start with that. 1 cubic centimeter over 13.1 grams. Okay, I don't need no stinking formulas. I got dimensional analysis. 65.5 grams. Right, that guy cancels that guy. My grams go bye-bye. My cubic centimeters are left over. Let's put that over here in the answer. 65.5 divided by 13.1. That sounds a lot like 5 to me. Boom. There's your answer. Okay? It's right over here too. Let's move on. Question number 4. Suppose 70 grams of pure substance undergoes a phase change. The mass of the substance after the phase change is complete will be... it's still going to be 70 grams, everybody. Why? The law of conservation of mass. It applies in physical changes. It applies in chemical changes. This is just a phase change. That's a physical change. So this stays the same. All right, let's roll on. Number 5. Strontium 88, strontium 90 represent strontium isotopes with mass numbers of 88 and 90 respectively, which of the following features are different for a neutral, blah, 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 blah. All right, guys. The only thing different is the number of neutrons. So the total number of neutrons, that's different. Boom. Right there's your answer. All right, you can ignore the others. All right, total charge outside the nucleus. If they're both neutral, they have the same number of electrons, okay, because they have the same number of protons. So the total charge carried by the nucleus and outside the nucleus is the same. Total number of protons, if you don't have the right number of protons, you're not strontium, okay? So that's the same. That's your answer. All right, number 6. Diamond and graphite are known as 2 what of carbon? Allotropes. You guys should know that. The atomic number of sulfur is 16. Consider an isotope of sulfur whose mass number is 32. What does that tell me? I got 16 protons in sulfur, mass number 32. I also have 16 neutrons because 32 minus 16 is 16. Total charge carried by the electron cloud, okay, of a neutral atom. That means I got 16 electrons. My charge is negative 16. Okay, make sure you read the problems carefully. I'm not talking about the electron cloud. I'm talking about the nucleus. Read carefully. All right. Question number 8. Consider the chemical reaction A plus B makes C plus D. If 30 grams of A reacted completely with 70 grams of B and 40 grams of C were produced, then how many grams of D were produced by the reaction? Again, write down your reaction. A plus B makes C plus D. All right, draw a line through the middle. This side of the line has to equal that side of the line. You look at the mass. All right, the law of conservation of mass. 70 grams of B, 30 grams of A. Okay, 70 grams of B, 40 grams of C. How many of D were made? Well, there's 100. There's 40. I need 60 over here. Let's find 60. Hey, there it is. Number 8. All right, moving on. Question number 9. The atomic number of oxygen is 8. What's that mean? 8 protons, right? Atomic number is protons. 17 oxygen represents an isotope of oxygen with a mass number of 17. That means 17 minus 8 is 9 neutrons. Okay? The number of neutrons is equal to, we just wrote it down, 9. Moving on. Number 10. Which of the following statements best describes the electron cloud of a neutral atom in terms of density and charge? Electron clouds are very big compared to the size of the nucleus, right? And they are not very dense. Those electrons don't have much mass. Not very dense and has a negative charge, okay? Not very dense, negatively charged. That looks like D. Circle that guy. Moving on. All right. Again, I didn't try to format this, so I just did what I could. Which of the following occurrences best represents a physical change? All right. My options are on the next page. We're looking for a physical change. Sublimation of snow. Hey, that's going from a solid straight to a gas. That is a phase change. That's a physical change. Okay, you burn magnesium in air, you're making something new. Anything burning is a chemical change. Neutralizing vinegar with baking soda, that's your volcanic reaction that you'd make, right, in a lot of chemistry labs and stuff. Digesting food in your intestines, you're breaking that stuff down into simpler pieces, okay? That's a chemical change. All right, question number 12. Consider the chemical reaction X makes Y plus Z. If 70 grams of X reacted complete and 30 grams of Y was formed, how many grams of Z were formed? Dude, we just did this a little bit ago. All right, 70 grams of that stuff, 30 grams of this stuff. How many grams of wire made? 40. There it is. All right, moving on. 13, if you heat up a solid without melting, what happens to the particles? Hey, we've seen this one before. They're going to spread apart and move faster, right? I'm adding thermal energy. Those guys are going to vibrate. They're going to move. Okay, there you go. Remember, kinetic energy is related to temperature. You heat something up, they're going to move faster. All right, let's move on to question number 14. Next page. Ooh, this is a big one. All right, where have we seen this before? Well, we've seen it 2 or 3 times, haven't we now? All right, we took 4 regular shaped rocks, trim at room temperature, shown in the figure below, plopped them in some water. Each original water level was 30 milliliters. So we're at 30, 30, 30, 30 originally. Throw a rock in there. This guy goes up to 60. This guy goes up to 100. This guy goes up to 85. This guy goes up to 75. You're going to see this picture again, probably. Hint, hint, wink, wink, nudge, nudge. Remember this. 30. Okay, 60 minus 30 is 30 milliliters. That is the volume of the rock, believe it or not drawn to scale, right? 100 minus 30, 70. 85 minus 30, 55. And 45. Okay? Now, take those volumes we just calculated through subtraction and throw them down here. All right, there's my mass. Here's my volume. These are in milliliters if we really want to know. We got 30, we got 70, we got 55, and we got 45. Okay, now you're going to take column 1, divide by column 2, and that will give you the density. All right, because density is equal to mass divided by volume, or grams per milliliter. Will be my units in this case. All right, so I got a calculator. 55 divided by 30 looks like about 1.83. Uh-oh, lead's getting low here. There we go. All right, 1.83. 135 divided by 70 is like 1.93. Okay, yes, I'm rounding these off. Deal with it. 110 divided by 55, hey, that looks like 2. And 85 divided by 45 looks like about 1.88. Okay, I put these all close together. Good job, Mr. Holmes. All right, which rock had the highest density? That would be rock in cylinder number 3. 2 is greater than the others, right? So rock in cylinder 3 is right there. Circle the correct answer, okay? These are shuffled, so make sure you read carefully. All right, you guys got that? Initial volume of each was 30 milliliters. Threw a rock in there, the water level went up by the amount that the rock displaced. Okay, take the final volume minus initial volume, that gives you the volume of the rock. Okay, this is no rock, that's with rock. All right, put those guys over here by your masses. Take that number, divide by that number, you get this. That number divided by that number gives you this, so on and so forth. All right, find the one with the highest density. It was rock in cylinder 3. All right, down here at the bottom, the mass and volume data for 4 liquid samples at 22 degrees C are given in the table below. All right, so I got samples, mass, volume. They're on the next page. All right, here we go. There's my samples, 1, 2, 3, 4, my masses, and my volumes, right? Might want to write that on there just to remember. Okay, I will give you some scratch paper to work with for your final. You might need it. 10 divided by 5, that looks like 2. 9 divided by 4, oh, that's like 2 1/4. Or, sorry, yeah, let's erase that. Yep, 2 1/4, 2.25. Okay, sorry, my handwriting's not the best sometimes. 7 divided by 3, I'm in a bit of a hurry here. All right, 2.33. And 13 divided by 6 equals 2.17. What had the lowest density? Oh man, that's sample number 1. That was easy. All right. Okay. Question number 16. This is also a long one. All right. According to the table above, how do the 2 isotopes of fluorine compare in terms of the number of neutrons, electrons, and protons per neutral atom? Once again, I'm reminding you, when you find out what you're looking for, cross out the stuff that doesn't matter. We don't need chlorine. We're looking at fluorine. Right? We don't need potassium. We're looking at fluorine. We don't need carbon. We're looking at fluorine. All right. We are looking at fluorine. Okay. So what does fluorine have? Well, it's got 9 protons every single time. Okay. If you don't have 9 protons, you're not fluorine. 19 minus 9 is 10. So isotope 1, I'm going to put it down here, has 9 protons, 10 neutrons, and because they're neutral, it also has 9 electrons. This guy has 9 protons. 25 minus 9 is 16 neutrons, and it's going to have 9 electrons. So now we've identified what it has. We just got to figure out where that's at and all this, long, wordy answer choices. All right, 10 neutrons, 9 electrons, 9 protons. Hey, that's good. 16 neutrons, 9 electrons, 9 protons. Hey, that's good too. Let's go with that one. Okay, it's A in this case. Again, answer choices could be shuffled. Moving on. All right, look, we're already in question 17 out of 20. We are rolling. Let's keep it going. Magnesium and aluminum in the same period of the periodic table. Dude, we just did this a little bit ago. Consider the following features of a magnesium atom of an aluminum atom. 1, the total shells that contain electrons. 2, the shell that holds the bonding electrons. 3, the number of bonding electrons. Which of these features are different for the two atoms? Okay, this time we're asking different. Like last time we saw the question, it said which are the same. That might be why some of you guys got this question wrong. Okay, read carefully. All right, read very carefully. Don't try to rush through your test. All right, as we said before, if they're in the same period, they have the same total number of shells. Also, it's the outer shell that holds the bonding electrons. So those two are true. Number 3 is different. So only 3 is different. All right, there it is. Question 18. Elements in group 18 are classified as, hey, that's easy. That's noble gases, right? That's way over there on the far right-hand corner of the periodic table, or the right-hand column of the periodic table. All right. Number 19. Elements from which of these groups of the periodic table are most likely to be shiny and ductile? Shiny and ductile. That sounds like a metal. Noble gases are not metals. That's not the right answer. Nitrogen groups. Those are a mixed group. Most of them are nonmetals. Halogens, nonmetals. Transition metals. Dude, those are going to be shiny and ductile. That's the right answer. All right. Number 20. Finally and at last. The atomic number of oxygen is 8. Oh, what does that mean? 8 protons, guys. Atomic number is the number of protons. Consider an atom of oxygen whose mass number is 17. What does that tell me? 17 minus 8 would be the number of neutrons, which is 9 neutrons. All right. And has a charge of 2 minus. How many electrons would be found in this atom? Ooh, easy. 8 protons, 10 electrons. 10 negatives, 8 positives. That gives me a charge of 2 minus. All right. So I got to have 10 electrons. There's my answer. Okay. Boom, we're done. Hey, kids. This video presentation has been brought to you by Mr. Holmes, Strong Coffee, the color green, and the number 7. Thank you very much. Bye-bye.